Solving a rational equation is similar to adding and subtracting rational expressions. First step is to find the least common denominator. In this example, all the denominators have already been factored. So the least common denominator for the first rational expression is x minus 1. Common denominator of the second rational expression is a 9, so I have to include that. And the third rational expression is an x minus 1, but I already have one. Secondly, I'm going to multiply the numerator and denominator of all of the rational expressions by any of the missing factors from the least common denominator. So my first rational expression, which is 8 over x minus 1, needs to be multiplied to a 9 over 9. The second rational expression, x minus 8 over 9, is missing the x minus 1, so I'm going to multiply the numerator by x minus 1 and the denominator by x minus 1. Third rational expression, 10 over x minus 1, is missing the factor of 9 in the denominator, so I'm going to multiply the numerator and denominator by 9. Once I have all of the denominators the same in a rational equation, if I were to multiply both sides of the equation to get rid of the denominator, they would essentially all cancel out. So I'm left with just the numerators to multiply, combine like terms, and solve. So 9 times 8 is 72. X minus 8 times x minus 1 multiplies to x squared minus 9x plus 8, and this is equal to 90. Since this is a quadratic equation, I need to set it equal to 0. So I get x squared minus 9x plus 80 equals 90. Now I'm going to subtract 90 from both sides to set it equal to 0. I have x squared minus 9x minus 10 equals 0. I need to factor the left side of the equation. If I were to do MAF, two numbers that multiply to negative 10 but add to negative 9 are negative 10 and positive 1. Now I can set each of these factors equal to 0. X minus 10 equals 0, and x plus 1 equals 0. When solving for x, I would add 10 to both sides here, leaving me with an x equals 10. Here I would subtract 1 from both sides, leaving me with an x equals negative 1. I also need to check for extraneous solutions. So by doing that, I would take each of these solutions, put them into the original equation, and in this case, I would be on the lookout for any of these solutions that give me a denominator of 0. In this example, I do not have that, so there are no extraneous solutions. X equals 10 and x equals negative 1.